Hi, I'm Reema, and this is my report for Lab 1. So the purpose of the lab was to observe differences between a predictive model and a real experiment showing same speed and same direction motion. The physics principles shown in this lab are Newton's first law, the velocity update, and the position update. So Newton's first law states that an object stays in consistent motion unless acted upon by an external force. This is relevant to our experiment because we're observing a consistent motion. In the lab, in the computational model, we pretend that there is no friction acting upon the marker and that the gravitational and normal forces cancel out. So since there's no external force, the initial force that gets the marker in motion is the only thing that contributes, and the motion will stay consistent. The velocity update formula is the final velocity equals initial plus F net over mass times the time of the experiment, and position update is the final position equals initial position plus the average velocity across the experiment times the time. Overall, data was relatively the same between the computational model and the experiment. The data from Tracker in our experiment showed more variability from the linear model and GlowScript for a couple reasons that will be discussed later. The system for the experiment was the marker because that's the object being observed, and the surroundings were the table because that exerts friction upon the marker, and a person who pushed the marker to get it into motion. The initial conditions were laying the marker flat on a flat desk with the meter stick above it, and the initial position and velocity were recorded at the start of the video, and the velocity stays fully consistent after. The steps for the experiment were laying a marker flat on a desk with the meter stick above it, pushing the marker for a few seconds to get into motion, and recording the marker rolling parallel to the meter stick. We then uploaded the video to Tracker to get data on position versus time on the experimental motion, and then created a program in GlowScript to predict the motion based on the recorded initial velocity. But the GlowScript model basically ignored all external factors like friction. And then we compared the data from both programs to analyze what could have caused the differences. So this was the code for GlowScript. Line 35 gives the initial position, and we made that the origin. 36 gives the velocity vector, and that was the velocity we recorded from Tracker. The time step was made to match the one in the Tracker data. The while loop iterates through time steps until the experiment is completed, and line 59 has the position update formula given earlier in the presentation. And there's no velocity update because since there's no F net, the entire part of the equation gets canceled out, which just means the final and initial velocities are equal. This was Tracker. We made the pink axis line go parallel to the marker's motion. The graph at the top right shows a close to linear relationship between position and time, indicating that the motion was very close to being constant, with a few exceptions. And the table on the right was the data that we put into the Excel sheet to give us a graph of the GlowScript versus Tracker data. As you can see, the data is very close with both. The variation is likely due to friction because the Tracker accounts for the real data and GlowScript ignores friction and other external forces. So one possible source of error could have been setting incorrect parameters in Tracker for like when you had the meter stick in front indicating what length at one point was happening. And the table could have been angled, which could have affected the acceleration. If we flip the axes in Tracker, position would have been shown as going in the negative direction. However, velocity would have been the same magnitude but in the opposite direction, meaning that the speed would be the same. It is possible to tell what forces make the net force zero. Gravity force and normal force cancel out as shown in this force diagram, and there would be no force in that scenario. In reality, though, there is friction from the table, so that friction basically contributes to the motion slowing down a bit. So there is a very small acceleration, but it's pretty much negligible in this scenario. Thank you.